finish up this thing for exercise 7 by showing that if we have an A and B that lie inside the AB region for the negative binomial distribution, then the probabilities defined using this recurrence relation will give rise to a negative binomial distribution. And we will try to figure out how the parameters suit inside this thing as well. So, well, let's see. Let's start by choosing A and B inside this region. So we have to fix an A that is somewhere between 0 and 1, and we have to choose a B so that A plus B is greater than 0. What we do next is, as in the earlier exercises as well, we will look at how the QKs look in terms of the previous Qs and try to write up QK as an expression of Q0. So let's look at Q1 first. Q1 is A plus B divided by 1 multiplied by Q0, right? And Q2 is equal to A plus B divided by 2 multiplied by Q1, which is in turn A plus B multiplied by Q0. Let's also just take Q3 for fun. Q3 is equal to A plus B divided by 3 multiplied by Q2 that we can just plug in here. And so it seems like we have a pretty solid expression to go on. And what we see is also that A occurs in all three terms. So a thing that we can try to do is to take out the A in each of the terms. Now there's one A that I take out of this parenthesis, and that will leave me with 1 plus B divided by 3A. And because I also have to divide by 3 in both terms. And then in the next parenthesis, I can take out another A, and that will leave me with 1 plus B divided by 2A. And in the next one, I can take out another A, which leaves me with 1 plus B divided by A, Q0. Now, one more thing that I can actually notice as well, which will come in handy in a second, is that, well, I want to try and rewrite these probabilities into something that have to do with the negative binomial distribution. And inside the negative binomial distribution, I definitely have to divide with k factorial at some point. So I kind of want the 3's and 2's outside as well. So I can see that I have A here, and now I can try to factor out the divided by 3. So I have 3 plus b over a. And then I have a, I factor out the divided by 2, and then I have 2 plus b over a multiplied by 1 plus b over a, q0. And what I see now is I can gather the a terms, so I have a to the third, and I have actually also got, well, 3 plus b over a, 2 plus b over a. So a pattern is kind of emerging here. And I can divide all of this by 3 multiplied by 2 multiplied by 1, which is, well, you guessed correctly, 3 factorial. And when we generalize this, we can be pretty much sure that qk will then be a to the k multiplied by k plus b over a, k minus 1 plus b over a, and so on until the kth term 1 plus b over a divided by k factorial multiplied by q0. And what can we see from this? Well, first of all, we haven't really shown this yet. You can show it using induction, just as we did in the binomial case. So we will skip over the induction proof and just take this as a fact of life. Well, we can notice something here, right? Because what we notice is this thing is basically just the binomial coefficient of k plus b over a choose k. Because here we have k plus b over a, and then we have the same minus 1, and then the same minus 2, minus 3, and so on until minus k. So there are k terms here. And what we have then is this is k plus b over a, choose k, multiplied by q0. Now we still kind of have a problem because in a second, we will need to sum these things. We will need to sum all of the qk and try to find out what that evaluates to, because we want to sum all of these, require that the sum equals 1, and then find out what Q0 can be. So what should we do now? Well, when we sum this, we'll have to need a formula to find out what the sum is. Now, normally, we use the binomial theorem that we see over here. But we won't be able to use the binomial theorem because k, which should only be down here in the binomial theorem, is also part of the entire sample size that is up here. So we have to rewrite this, and in order to rewrite, we will use something that we spoke about in one of the detours I took in an earlier video, which is that I can take a binomial coefficient where k is both up here and down here, and I can remove the k in the upper number by factoring it out using a minus 1 on each term. So it's this rule that we proved earlier that I'm going to use now, which gives me that I can take out minus 1 to the k, and what I'm left with inside is minus b over a. And in fact, over here, their version of b over a in this formula is b minus 1, right? So essentially, we also have to add a 1 for this to work for us. So let's just rewrite a little bit on the top so there is no confusion, because there is probably a bit of confusion right now. We want to use the formula for this. So our v will be b over a plus 1. And when we have used this formula, we need to end up with minus v, so it will be minus b over a minus 1. Choose k, q0. So now we can sum the qk's. So for k from 0 to infinity, the sum of qk's is equal to q0, and then the sum of minus a to the k, and then b over a minus b over a minus 1, choose k, and let the sum run from 0 to infinity. Now I can apply the binomial theorem that I have here, which tells me that the sum evaluates to 1 minus a to the minus b over a minus 1. And this implies, since this sum of probabilities should be equal to 1, then we have that q0 is equal to 1 divided by all of this, which is 1 minus a to the b over a plus 1. Okay, so now we have q0. Let us also write up what qk should be. Now qk in terms of q0 here, it is minus, well, maybe we should just write it using the notation above. So it is k plus b over a plus 1 minus 1, choose k, multiplied by a to the k, multiplied by 1 minus a to the b over a plus 1. So we can actually kind of recognize the negative binomial distribution here now. So we can see that the qk are point probabilities in the negative binomial distribution with parameters, Well, what is our V parameter here? Our V parameter is essentially this B over A plus 1. And what is our probability parameter? Well, our probability parameter and our A, they're kind of switched, because in the negative binomial distribution, your P parameter is the one that is the success probability, whereas here 1 minus A is the success probability. So our P parameter is 1 minus A. And then we have now figured out that using the A's and B's in the region that we have chosen, the QK are point probabilities in the negative binomial distribution with parameter B over A plus 1 as V and 1 minus A as the P.